The Galton machine is also known as Galton board or Galton box, and it was made by Francis Galton in 1893. He was an English mathematician who was an expert in many scientific fields. He created the Quincunx machine to demonstrate how a normal distribution is formed through the occurrence of multiple random events. The Galton machine requires many mathematical and statistical concepts, including the normal distribution, the central limit theorem, the binomial distribution, the regression to the mean, binary numbers, and more. So what Francis Galton referred to as the law of unreason. The main function of the Galton machine is to demonstrate the central limit theorem. This device also brings to life the statistical concept of normal distribution. As you rotate the Galton board on its axis, you set into a motion a flow of steel breads that bounce with equal probability to the left or right through several rows of pegs. When the breads accumulate into the bins, they approximate the bell curve as shown by the yellow line on the Galton machine. This hands-on Galton board allows you to visualize the order. This device has a lot of functions, but it's mainly helpful for binomial distribution and normal distribution.
We use binomial distribution in a Galton machine to find the probability, to calculate the success, the failure, and the outcome of an experiment. In order to find the probability in an experiment, we use the following formula. Each time a ball hits one of the nails, it can bounce right or left with some probability. P and Q equals 1 minus P. For symmetrically placed nails, balls will bounce left or right with equal probability. So P and Q equal 1 over 2. If the rows are numbered from 0 to n minus 1, the path of each falling ball is an Bernoulli trial consisting of n steps. Each ball crosses the bottom row hitting the end peg from the left, where 0 is smaller or equal than n, and n is smaller or equal than n minus 1. If it has taken exactly n right turns, which occurs with probability. In conclusion, this process gives the rise to a binomial distribution of the heights and heaps of balls in the lower slots.
The Galton machine and the relation with normal distribution. First of all, we'll start by defining normal distribution, which is a probability distribution that is symmetric about the mean, showing the data near the mean are more frequent in occurrence than data far from the mean. In graph form, normal distribution will appear as a bell curve. Normal distribution is also a probability. It's really normally seen in real life situations. For example, tossing a coin, shoe size, and birth weight, which these two are mostly to see the gain and how it goes low, etc. And also by rolling a dice. Since my teammate Daphne already explained what the Galton machine does, now I'm going to explain what's the relationship between this machine and the normal distribution. First of all, the machine rotates on its axis, just into motion a flow of steel bits that bounce with an equal probability, to the left or right through several rows of pegs. As the bets accumulate in the bins, they approximate the bell curve. The bell curve, as I mentioned before, it's one of the main characteristics of the normal distribution. As shown by the yellow line on the front of the Galton board, this hands-on Galton board allows us to visualize the order embedded in the chaos of randomness. So in conclusion, what's related to the normal distribution with this machine, it's actually the bell curve, which is one of the main characteristics of the normal distribution. On the pictures down below, we can clearly see the resemblance with these two, the machine and the normal distribution. We can see the bell curve on the first picture, and also on the second one, which is a normal distribution example of a graph. Next, we're gonna see a video of the Galton machine being used.